Yes, hello and welcome to the Data Spaces in Mobility session. It seems that Ulrich just disappeared. So Roberto, I would ask you to go on, please.
Go. Thank you. Good afternoon and welcome to this Data Space in Mobility session. I'm Roberto Di Bernardo from Engineering Informatica. I'm here representing the Smart Cities Domain Committee FIWARE, and I will drive you along this session. Making a link with the previous session on smart living, I would say livable urban environment has become one of today's most pressing issue, and definitely mobility is a cornerstone of urban liability and sustainability. Now the question is, how can data spaces can support new mobility scenarios, and which are the possible steps that can make this real? For this, the session will provide you with ideas, with a concrete example, and further development on European mobility data space. First, I'm honored to introduce you to our keynote speaker, Dr. Reynolds Akats. He is president and board chairman at International Data Spaces Association, with more than 40 years of experience in relevant industrial groups like Siemens and ThyssenKrupp. He is currently supporting company and organization in development innovative, sustainable, and resilient strategy and solution. Of course, a key topic of his interest is about implementation of mobility data space, and is supporting ACATEC, the German Academy of Science and Engineering, in this respect. Please, Dr. Akats, the floor is yours.
Yeah, first of all, thank you very much, Roberto, and thank you very much for inviting me. Now, my idea is to give you in the next 10 minutes a short overview about our mobility data space. And I think we clearly can say this is a new paradigm how to share data. And I think I will explain it to you in the next 10 minutes, so you will definitely understand why I believe it's really a new paradigm. And I think when we basically come to my presentation, it will be a short definition of data sovereignty. I will talk about the requirements for sovereign data spaces. I will talk about the generic structure and key components. I will explain the difference between data lakes and federated storage systems or federated systems. I will describe how we make data available. I will talk about the details of mobility data space, explain some use cases, and then I will summarize. Yeah, starting with data sovereignty, I think it is the right and the possibility to share data without losing ownership over their use. And I think this is something I believe is very important, because if people understand and companies understand that they can keep the data in their premises and basically sharing them only for a specific purpose, obviously the openness to share is much higher. What are the requirements for such a data sovereignty? And I think, so first of all, it's interoperability and standards, because obviously if you cannot connect, and if you obviously there's no standard where you can connect, there will be no sharing. And the International Data Spaces Association, for that reason, contributed to the DIN standards, the 2770. And this will be an ISO standard very soon. On the other hand, obviously, to share data, we need trust. So international data spaces this defined certification and identity management. So we basically implemented trust by design. On the other hand, basically, to really make ownership happen and data sovereignty happen, we defined user conditions, and those user conditions are added to the transfer data. And so obviously you always have a connection between the user conditions and the transfer data. And last but not least, obviously we have a metadata broker which publishes all data in one defined format. And in this way, basically, we always can create a win-win situation between the data user and the data provider. And I think this is something is very important as well, again, to ensure the willingness of people to share. What are the key components we are using here in IDSA? And we basically always need a connector. That means if you want to have access to the data space, your input, your door, your way of sharing and getting data is a connector. And everybody basically with a certified connector can have access to the mobility data space. On the other hand, as I discussed earlier, we have a catalog where you basically find the data. The catalog only contains metadata. That means the data stay with the owner, but basically the owner shares a description of the data, the metadata. On the other hand, we have an identity provider to ensure identity. We have a vocabulary, which is obviously necessary to standardize syntax and semantics. We have definitely a clearinghouse, where you can document your transfer, because obviously if you want to basically charge somebody for the data shared, there is a proof necessary, and obviously this proof can be created with a clearinghouse or with a logbook. And last but not least, we offer an app store to make implementation easier. I think that is something which is a common activity today. Now I would like to come to the difference between sharing data in a data lake, as basically all big companies do, like Amazon. This is a picture from Amazon on the left, right, basically where everything is put on a data lake. And Amazon is the key user of the data lake. So Amazon is basically then, and all the other big hyperscalers are basically in the position to do everything with the data. And the original owner of the data loses control over the data because they are now in the data lake. This is exactly the opposite in a data space. In a data space, the data stay with the owner and are shared only for the purpose which is described and which is agreed on with the user of the data. And this way, obviously, and as I said earlier, with the usage condition, you always have control who gets your data and what the user of the data will do with the data. And the data obviously created in real life. So we have all kinds of elements and components in real life which create data. Normally, those components have a digital twin. And this digital twin then is able to share data or even connect to companies and programs, basically, which use the data. But there are other data available as well, which are not coming from real life, like weather data or train schedules or you name it. So basically data which are available in the internet, and those can be accessed through the mobility data space as well in a free way and normally without any charge. And the real value is created by all the users. So basically with the mobility data space, we are only offering an infrastructure which I think has a low incoming hurdle, which basically allows us to freely share data between the users. And the real value, as I said earlier, is created by the users, because having those data available now, they basically can create all kinds of business models and business cases. And I think this is the key element. And the good thing is the more news users are participating, the more data are available on one hand, the more the data are used. And obviously, this creates a even bigger business opportunity. So basically, sharing data and giving access to data creates business opportunities. Before I come to the end of my presentation, I give you some input about existing use cases, because I think the great thing of the mobility data space is that it's really used. I think, and we have different elements in it. Obviously, we have areas where convenience and smart mobility is supported. We have areas where safe and reliable mobility is supported. Sustainability is an aspect as well, and obviously a contribution and a participation in the data ecosystem is one element as well. So on one hand, you can check in a data space basically how to use a rental bike or a rental scooter and what is the best way of doing it. You as well can have access to the status of your electric vehicle or the fuel status, or you have access to information from the railway situation. Basically, are there any disruptions in my railway plan? On the other hand, you can plan traveling in different ways. And I think, obviously, I would like definitely mention the FIWARE smart mobility case, mobility as a service, where basically a lot of support is offered for people traveling from A to B and with a lot of information and additional information. On the other hand, parking is always a big issue when you drive with your car. So there are different ways of supporting parking. So Mercedes is doing that in a general way. And again, we have a great FIWARE use case in the city of Wolfsburg, where parking is combined with shopping. And we basically have as well the ability to park in areas basically where visitors are going there. This is offered by OptiPark. Yeah, as I now see that I'm coming to the end of my presentation, I skipped the other use cases and would like to summarize. So basically, the value proposition is data sovereignty, which is created, and I think I explained how it's created. Then obviously, we enable value creation through data sharing. That's really great, and this is something which is the key element, so allowing new business models. Interoperability is ensured through standards. It's open and vendor neutral. I think this is very important. Everybody has the same opportunity, so nobody is preferred. Trust is implemented by design. And we have, in the moment, no transaction cost and in future low transaction cost because it's supported by a non-for-profit activity. And obviously, then the whole thing scales. We can use economy of scales. And with this, I'm at the end of my presentation. I thank everybody for listening. And if you want to know more, either you contact me or the Mobility Data Spaces organization, or you simply go on the website. Thank you very much.
Many thanks, Reynolds. Many thanks for your presentation. I already took several elements from your presentation. Of course, the concept of trust, the concept of data sovereignty, and in particular the equal opportunities on a win-win approach, and open and vendor neutrality that is in the heart of FIWARE strategy, of course.
And the great thing is that FIWARE is really participating in it, so that's something I think which is a very good cooperation, and I want to say I very much appreciate that.
Thanks for this. Now, with the idea of equal opportunity and economy of scale, I would pass the floor to the other two speakers today, that are two entities that represent the players in the sector of ICT and smart mobility. I will pass now the floor to Clara Pezuela from Atos. She has been involved in Atos since more than 20 years now. She is innovation officer and CTO officer in the public sector and defense industry. And she is a member of technical steering committee of FIWARE Foundation and president on behalf of Atos of the Spanish technology platform for digital technologies. Clara, please, the floor is yours.
Thank you very much, Roberto. Thanks to the FIWARE Foundation for the opportunity to present the vision of Atos in the context of smart mobility and the required data space creation to make real the future scenario of having a more comfortable, sustainable, and rational way of moving within the cities. So in our view, mobility is very related with emissions and climate challenge, as around 60% of the total emissions are caused by the traffic. And therefore, an improvement in the way we move within the cities has a direct impact in the reduction of the CO2 emissions. Atos is really committed with the decarbonization of the society. So the monitoring and improvement of mobility in cities is one of our major focus. Smart mobility is not just a technology challenge, it's a societal change process that cities and communities need to start, and here is where Atos can support. Cities are starting initiatives to change the offer mobility services to reduce local emissions and inspire citizens to use alternative mobility options. As citizens, we should be better informed on the impact of our daily choices. The real impact in cities to reduce local emission is our personal behavior in travel. Technology may help citizens to be aware of the emissions of their choices and may help cities to monitor emissions and actuate over the traffic as the main cause for them. Other drivers, like allowing accessibility services for disabled people or reduce the number of accidents in roads, can be also supported by the technology. Thus, smart mobility is not only the redesign of transport modalities to lower emissions, but is focused on sharing information to support this change. Share better information on travel options is a complex matter, as it involves the data from all available transportation options, combined with actual traffic data, weather data, pollution data, and of course, our personal schedule and preferences. All this data will conform the data space for mobility. As all data spaces, this one will require an ecosystem of players, clear governance of the data and partners' roles, and a digital platform to manage the data and all the services around. We have been working in some cities in mobility projects using our urban data platform powered by FIWARE. And I would like to highlight the work done about traffic monitoring and air quality impact by sharing data between the traffic management system of the city and the in-situ sensor for pollution. It's also worthy to mention the solution for cooperative intelligent transport systems, where a network of nearly vehicles in a road or in a street can communicate each other in order to have, for example, traffic information, receive alerts or incidents, or parking guidance. Apart from other cases like autonomous vehicle or bicycle routes management, we have started recently a project which may have a significant impact on FIWARE community. Its Green Move project is a CEF open data project of 2 years duration in a consortium with some relevant partners and FIWARE members. The main mission of Green Move is to harmonize the different types and formats of data we may find in a mobility scenario, to develop mobility services which combine the availability of diverse mobility modes and the reduction of pollution in cities. This mission implies a set of technical challenges, like to define or to extend smart data models, for modeling the different data sources, to combine the different data sources in order to provide valuable and replicable services for the cities, and to recommend the best architecture and configuration of the context broker, potentially federated to respond the demanding scenarios of mobility in the project pilots. So this list of outcomes could be of value for the community. Besides, 3 valuable pilots are participating in the project. In case of needs, their goal through the project is to monitor air quality and noise to actuate over the traffic when the pollution is higher than usual. For Murcia and Molina del Segura, very near cities sharing an university campus, the main purpose is to predict the traffic impact in the air quality of the city. And finally, for Flanders region, the goal is to forecast the availability of the bicycles at train stations. For all the cases, the ultimate goal is to improve in a more sustainable way the mobility of the city. We believe that the project outcomes may contribute to a better data sharing, specifically in the context of green and smart mobility, from the perspective of defining specific data models for the creation of a common data lake and the provision of services which exploit the aggregation of data from that lake. Here we show the already identified models and services to be provided. Some of them are shared by some of the cities, fostering the reusability and replicability of the services, and the data models will be actually used and mapped to real data sets available in the cities. There are indeed many other challenges and angles to be tackled in the data space, and that's why we bet for an open and inclusive data space where many partners can contribute with their previous experiences and outcomes. Having a clear and easy to understand governance will be very key for the success. And then the key challenge is interoperability, so it must rely on recognized standards. It must find the inclusion of existing initiatives and liaison with related entities. And the data space must seek the benefit of people, companies, and governments beyond the technological advance. So establishing solid and practical basis and tangible scenarios and use cases is pretty much a mandate, in my humble opinion. As members of several of these initiatives, Atos will join forces with the Data Space Business Alliance as member of the 4 organizations in the alliance: FIWARE, Gaia-X, ITSA, and BDBA. And let's remind, the smart mobility is more than a technological challenge. It's a change of mindset for citizens and cities, with data sharing at the core. So I would like to thank you very much for your attention, and to the organizers again for the opportunity.
Many thanks, Clara, for your presentation. I took some point. I will recap it at the end of the session. Now I will move directly to the other speaker. I'm introducing you to Pier Savero Spinnato. He is a senior researcher and project manager at Engineering Informatica, IT expert, solution designer, and developer, and technical responsible. He is involved in several European projects. In particular, he is technical coordinator of MyPass, an Italian project to design, implement an innovative digital solution for mobility as a service. Pier Savero is also leading the European Task Force for Data Management and EU Nature-Based Solution Knowledge Repository. Please, Pier Savero, the floor is yours.
Thank you, Roberto. Hello all. Can you see my presentation? I think
Absolutely fine. Yes.
Okay, thank you. Okay, now I show you the potentiality of data spaces for urban mobility according to the vision of Engineering Informatica. And the engineering, as you know, is a very big enterprise with more than 450 data scientists and researchers active in more than 100 research projects. And we are active in several countries in Europe, America, South America, and also in Asia. Engineering really believes on the ambition of openness, open source, open innovation, open government, and also support the principle of cooperation and data sharing. For this reason, engineering promoted and participated as a board member in several European initiatives like FIWARE, Gaia-X, International Data Spaces, and also is active member in other initiatives like Water Europe, Network Europe, and so on. We are also partner of OASC and supporter of Living in .eu. This because we know that we are all contrasting with several data challenges in urban mobility, because every day we are observing an increasing diversity and number of traffic types, and also the need to interconnect heterogeneous silos, existing IoT architecture, and also legacy system. In this context, we also observe a fragmentation mix of different systems for managing the infrastructure, and also a different need for orchestrating the activities of different actors involved in mobility urban services. For this reason, we know that it is necessary to agree a set of standard mechanism and data model ensuring the interoperability, but also we need to agree the common policies for ensuring data sovereignty, privacy, and also the trustworthiness. So according to that, the vision of engineering regarding the data spaces for urban mobility is based mainly on 3 concepts. From the bottom to the top, the first one is the need to allow and enable the possibility to create trusted multi-domain data spaces. This in order to permit the possibility to find the data and to leverage the value of the data distributed in different nodes. We have also to use the capabilities of the decentralized devices in order to permit to implement energy saving criteria and also to preserve the privacy of the users that connect their own devices. In this context, the smooth interoperability among the distributed heterogeneous data nodes is another main pillar to be implemented. This will leverage the standard technologies and data models, as I said, but also it will permit to create cross-domain correlation between the data coming from heterogeneous data sources and also at different scales and like geodata models or historical measures. On top of this main principle and concept, we have the urban digital twins that are a set of artificial intelligence and machine learning techniques that will permit to elaborate the huge amount of this data and provide simulation, real-time prediction that will permit to help the decision makers and the management of the urban mobility services. This vision is in line with the architecture for data spaces promoted by the European initiatives. So we know that data spaces for mobility will permit us to create a set of innovative, very interesting new services like services for simulation for smart urban planning or the impact simulation in order to permit the evaluation ex ante of the impact of the urban mobility services on the quality of life of city, like the simulation of the reduction of the air pollution, congestion, noises, and the increasedness of the happiness and the quality of services. So we also will be allowed to create personalized multi-experience services that will permit to augment the possibility to have a personal user experience and also the possibility to provide the intelligent and proactive alarm system, make automatic the infrastructure like bridge or cross lights. We will be also allowed to create the predictive maintenance plan and to allow the intelligent switch mode selection for the devices in order to decrease the energy consumption and make more efficient the devices. Currently, we are experiencing these challenges and also experimenting our solution in several projects. One of these is MyPass, where I am the technical leader, but we are also collaborating in Urban Age and Urbanite projects. In this context, we are proposing our asset, namely Digital Enabler, specifically tailored for urban mobility. And this asset provide a set of mechanisms for interoperability and artificial intelligence tools that support the creation of harmonized data models, but also the formalization of the citizen behavior. The digital twin is allowing the creation of decision support system, supporting, as example, the adaptive, sustainable road management, but also the possibility to provide dynamic clearing, flexible fares, and
Sorry, Saverio. we need to close the session. Could you wrap up?
Yes, this is in line with the also this is in line with the architecture for data spaces promoted by the European initiatives. That's all.
Thank you.
Thank you.
Thanks a lot.
Bye.
Thanks a lot to all the speakers for this session. Some keywords: decarbonization, involving citizen changeable behavior, and replicable services and common policies. Now I need to switch and to leave the floor to the CEO of FIWARE, Mr. Ulrich Haller. Please, Ulrich, the floor is yours.
Yeah, thank you. And just to thank all the speakers, to thank Roberto, to you for this explanation on smart mobility, on mobility data spaces, and also welcoming our guests and participants from South America. I see that a lot of people from Argentina, Brazil are dialed in now, from North America. So a very good morning to you. And we saw that the mobility data space, that smart mobility is an enabler for change of how people get from A to B. And this will definitely support also the Green Deal, which is driven by the European Commission. And this will be part of our next session starting now. Thank you very much.